Hi everyone, this is Mr. Ahlers, and we're doing 7.1.1. I'm really sorry that Julio's leaf blowing right now. Hopefully you can't hear it too much. Number one, just trace the triangle to the right with tracing paper. I'm not going to use tracing paper. I'm going to use our pen here. And then it says rotate it around the midpoint. Do our best. And this had double angles. This had single angle and this had double angles. So, check. Is Carlos? Yes. So right here, I think this angle is congruent to this angle. And this angle is congruent to this angle, which means those are opposite interior angles. So those angles make these lines. The blue ones make these lines parallel, and the red ones make these lines parallel, which makes it a parallelogram. What else can congruent triangles tell us about the properties of parallelograms? Opposite sides are congruent. Opposite angles are congruent. I think diagonals bisect each other. But diagonals are not congruent. Definitions are building blocks of geometric proofs. For example, by definition, a parallelogram is called out two parallel sides. You can use the definition of a parallelogram and another parallelogram as a starting point to prove points and properties. Does the diagonal of a parallelogram always split the quadrilateral into two congruent triangles? So these are parallel, and these are parallel. And then essentially, because those are parallel, we know that this angle and this angle are congruent because of alternate interior angles. And then these two are congruent because of alternate interior angles. And then we know that this is congruent because of the reflexive. So the triangles are congruent because of angle side angle. And there's the proof for you all. Given these lines are parallel, definition of parallelogram, these angles are congruent, and these angles are congruent because alternate interior angles. This is congruent because of reflexive property, and then the triangles are congruent because it's angle side angle. Extend your flow charge. I'll just move this down here. says extend your flowchart to prove the opposite sides. Well, if these triangles are congruent, then we know this side and this side are congruent because of all CPCTC, and then we know that this side is congruent to this side because of CPCTC. So you could say Alright, 73. Kip is confused. He put two triangles from problem 1 together, shown on the right. But he's not get the parallelogram. What transform did he use? He used a reflection. See definition of polygons in math notes, lesson 1. What shape does he makes a kite? Because he has two pairs of consecutive congruent sides. What congruent triangles tell you what the properties of this polygon? One pair of opposite congruent angles. These ones may or may not be congruent. What congruent triangles tell you what the diagonals of the polygon? This right here gets bisected, but the other one diagonals bisect the pair of opposite angles. The diagonal bisects a pair of opposite angles that are not necessarily congruent. So right here, this diagonal bisects this, so these are congruent and these are congruent. These are congruent and these are congruent. I'm really sorry about the leaf blower. Hopefully it'll be done soon. You can skip this one. .5. Kip finds out the kite with his teammates. Carlo wants to learn more about diagonals of a kite. Sketch diagram. Trace this diagram while tracing paper carefully. Add another diagonal. With the team, consider how the diagonals might be related. If it is a kite, then diagonals are, what do they look like? Perpendicular. What's a perpendicular mean? And the other one would be, if it is a kite, then one diagonal bisects the other. So this diagonal bisects. So if it is a kite, one bisects, one diagonal bisects the other. Prove this. She draws a second diagonal. She knows she's created two triangles. If any of these triangles are congruent, then they must be able to help us prove conjecture in part B. Are these congruent? we know that triangle FGE is congruent because of the transformation. There's like a reflection. And then we know that FG is congruent to HG because of CPCTC. We know that these angles are congruent because of CPCTC. And we know that this side is congruent to itself because of the reflexive property. So triangles FGJ is congruent to HGJ because of SAS. And then we can say that FJ and JH are congruent because of CPCTC. And then we know that these two angles are congruent to each other because of CPCTC. So if J is the midpoint, because these sides are congruent, like we know that this bisects this portion, which is one thing that we've learned. And then we know that if these two angles have to add up to 180 and they're congruent, what do they both have to be? They both have to be 90 degrees to their right angles, which means that these two diagonals bisect each other. Kind of hard to follow maybe with me talking, so I'll take a picture of the proof for you and you can see it. So these two were CPCTC, prove the triangles are congruent using SAS. Then I said the other parts are congruent because of CPCTC. If these two are congruent, then J has to be the middle, which means that this bisects the portion. If these triangles are congruent, then these two right angles are congruent. If they're a linear pair, then they both have to equal 180 degrees, which means they each have to be 90 degrees since they're equal, which makes those bisect each other. All right, last one. Examine the quadrilateral right with two consecutive right angles. What is true about MO and PO? If they're both congruent, perpendicular to the same line, then they're parallel. And the same side interior angles are supplementary, which makes them parallel. Write a conjecture. If a quad has two consecutive right angles, then it is a trapezoid. Prove the conjecture. You could say that one method, MNOP, has a pair of supplementary same side interior angles, so MN is parallel to PO. So since these are supplementary, these lines have to be parallel by the converse of alternate interior, the converse of same side interior angles theorem. And then you can say it's a parallel, it's trapezoid because trapezoids have at least one pair of one pair of parallel sides. And then here's the proof for y'all. Not necessarily. You could just have one right angle. This problem proves that quadrilaterals that work with the problem as called right triangle, or all quadrilaterals with right angles, right trapezoids. No, this one they have to be consecutive. But for instance, a kite could have two opposite angles that are right angles. But for them to be consecutive, then it has to be a right trapezoid. Your homework is down. Your homework actually tonight. Well, we're gonna skip these two. This homework is due 10:30, 10:30, or 10:31, based on what day you have math class. It's the day after the test. Because tonight's homework is test review, which some of you may have already done before, but you guys do test review. And then on Monday, we'll go over questions that you have. Hopefully, I'm here. See you all.